Okay, we are now in the second micro extraction method. Solid phase micro extraction is an extraction on a fiber. Okay, this name is not to be confused with micro solid phase extraction. Okay, when we talk about SPE just now, and then we have micro SPE, means that you are using particle sorbents. It means that they are on the physical state of particles. Okay. However, for solid phase microextraction, abbreviated as SPME, is an extraction on a fiber. What kind of fiber? Okay, so it is a fiber that has been coated on a solid phase, what we call as fused silica capillary. Okay, fused silica fiber capillary. Okay, sorry, not fused silica capillary, fused silica fiber. Okay, fused silica capillary is used in CE. Fused silica fiber, usually made of polypropylene, okay, is coated with this very thin coating. What kind of material? Is usually PDMS, polydimethylsiloxane. If you find out inside the internet, polydimethylsiloxane is a very non-polar coating. It's a very hydrophobic. So you can identify this as a reverse phase as well. Okay, sort of like reverse phase because it's using non-polar hydrophobic coating. Okay, so this is the PDMS as the stationary phase. Okay, the fiber, what is the procedure? The fiber is dipped into the aqueous solution containing the trace organic compound of interest, and then the organic compounds will diffuse and partition. Okay, the keyword is diffuse and partition. So partition is the mechanism used in liquid extraction. Okay, while in solid phase extraction in previous video, it is using adsorption mechanism. Okay, again back to SPME is based on partition, means that the organic analyte go into the fiber coated with the PDMS, and then it will be like position themselves inside the coating, and then when it comes into elution, the analyte will come off. Okay, so this is how it looks like inside a very small vial containing solution over here. You have solid phase micro extraction device is like a pen. It's more like a syringe pen. Okay, whereby we can like click and then the fiber come out. Okay, this is what we call as normal SPME, means that the tip of the needle with the coated PDMS is inside the solution. We also have what we call as headspace, means that this is solution, and then you just put your needle on above the solution, means that you are extracting the gaseous phase, means that anything that is volatilized can be volatilized. You can analyze with headspace SPME. Okay, let us watch a video provided by a manufacturer by the name of Guster on SPME. This is using
the Gerstel multipurpose sampler completely automates SPME with the thermal desorption unit. First,
this is automatic.
The sample vial is placed in the heated agitator. Once there, the sample is incubated to establish thermodynamic equilibrium between the headspace above the sample and the sample itself. The SPME fiber assembly is then inserted into the headspace of the vial and the fiber is exposed. Volatile analytes are then concentrated onto the coating of the SPME fiber. Once sampling is complete, the SPME assembly is moved to the hot thermal desorption unit where the analytes are desorbed from the fiber and pass into the CIS where they are focused prior to being heated and transferred to the GC column as a narrow band, providing better resolution, sensitivity, and detection limits. After analysis, the sample is returned to the tray and the MPS starts the next sample in the sequence.
Okay. So this is how automated SPME works, whereby it is very suitable for the routine analysis. Okay, just now the lady inside the video says that this is using TDU. Okay, TDU is thermal desorption unit, whereby here TDU here is the desorption system. Okay, desorption system, the one that analyte that has been partitioned inside the fiber, so we want to take it out, we desorb, just like how we desorb and elute the analyte inside SPE, but this time it is using heat. Okay, that's why it's thermal desorption unit. It is using heat, and this is suitable for headspace SPME. Okay, can also use for normal SPME. Okay, and then we move towards the next micro extraction method. This time, it is using a stir bar. This stir bar, it is coated with PDMS again. Okay, instead of in pen size, pen type, this stir bar is coated with a thicker PDMS coating. See here, it is thicker and therefore it will provide more extraction capability, 50 to 250 times greater than SPME, because we have a large volume of extraction. Sini, is thicker. Okay, so how does this procedure works? Okay, you have a sample. For example, if you have like you want to analyze like hydrocarbon inside, or maybe benzene inside sample. So you want to use PDMS, you put benzene with inside sample, then it will start to rotate. Why this rotate? Because this is a magnetic stir bar. It can rotate when you have a stirrer with magnetic ability. Okay, so what happened here? Only analyte goes in, so you can manipulate who goes in. Okay, by manipulating the solution, the pH and so on, while the rubbish over here all will be eliminated or will be discarded. We take out the stir, after finish, we take out the stir bar and put inside elution solvent. Okay, in this case, we cannot use very tiny amount of solvent, because we have to at least submerge the PDMS coated bar until it's full. Or you can also use TDU. TDU is usually available in GC. It is also a form of partitioning, suitable for hydrophobic analyte in volatile and semi-volatile aqueous sample. Okay, this is how it's done. Let's watch video again. See, this is cleaning, okay, dry, so that we eliminate the residual sample. And now we want to do desorption. So this analyst is using TDU to be put inside GC. Okay, unlike SPME, this method is like semi-automated. Okay, in SPME just now, it is fully automated. Means that it is very suitable to be used for routine analysis. For example, Jabatan Kimia Malaysia, Department of Chemistry Malaysia, and then forensic lab, and also in QA/QC department in factories. Okay, we finish on the extraction of organic analyte. Okay, now let us do active learning. Okay, active learning on extracting the information in journal articles. Okay, usually I do this kind of active learning so that you know what's happening outside, and when you want to do your own research or when you are working later, you know where to find the information. And for me, this is better to understand the procedure. Okay, I'm going to upload these journal articles in the e-learning, and please work in group. Okay, there are like 5 or 6 of you, maybe 3. Okay, and then please put your information, information that you can mind map in what we call as Kaggle. Find out what is Kaggle. Okay, in Kaggle, please add me inside that. Okay, add me by putting my email address like this. Okay, add me inside so that I can see the progress. So Kaggle basically is like the modern Mahjong paper mind mapping. Okay, so you can mind map your information extracted from the journal articles inside that, and then it can be downloaded as PDF and can be shared to other students. Okay.